One of the most important things that we need to understand when we're trying to solve algebraic equations is we have to know what type of equation we're trying to solve before we can decide how we would solve it. So when you're looking at all three of these equations here, right, we have this first equation A, B, and C, we have to try to find what characteristic sort of defines what type of equation they are. And one of the things you're going to look for is these are polynomials, right? You have variables raised to integer powers, added, subtracted together with coefficients. And once you know it's a polynomial, every polynomial has a degree. The degree represents the highest exponent of the variable. In this case, all of these exponents are 2. Right? The highest exponent is 2. So these are all x squared equations. Right? And we have a name for that. We call them quadratic equations. Right? So we say quadratic. Okay. I know quad sometimes sounds like 4, but these are called quadratic equations. And then the question is, okay, now that we know it's a quadratic equation, what technique are we going to use to solve it? There are basically 3 common ways to solve quadratic equations. Okay. The first thing you should look for is, can you set it equal to 0 and try to factor? Right? Set each factor equal to 0. Does it fit the square root method model? Can it be written as something squared equals a number? If so, then whatever is being squared can be plus or minus the square root of that number. Otherwise, if it doesn't factor and the square root method doesn't apply, then we have to resort to the quadratic formula. You might know the quadratic formula. It's one of these sort of common formulas that you learn and memorize. There are lots of sort of memory tricks and songs, melodies you can use to help remember this. If you have a quadratic, that's ax squared plus bx plus c equals 0, then the solution x is negative b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula always works. So no matter what quadratic you have, you can always do some work, put it in this format, and use the quadratic formula. It may turn out to take you longer than if you would have just factored it. Right? But if factoring is difficult for you, or the square root method is difficult for you, the quadratic formula does always work. We're going to focus in this video on what's the sort of most straightforward or most direct way to solve these 3 equations. So we'll focus on that. But you could always use the quadratic formula. It just may take more calculation and more time. Okay. So how are you going to try to solve each of these equations? We talked about the 3 techniques: factoring, square root method, or the quadratic formula. In a case like this, you already have it set equal to 0. You have multiple terms with variables here, so we want to look to factor. And factoring actually has its own sort of set of techniques. There's GCF factoring, there's difference of squares factoring, and there's the AC method, sort of the reverse FOIL factoring. In this case, there's a common factor, GCF. Right? Each of these terms, the coefficients are both multiples of 3. Each of these terms has a factor of x. So we would use the GCF, and in this case in particular, the GCF would be 3x. Okay, we'll solve each of these individually. I just kind of want to focus really on how to analyze and compare and contrast these, so you can use that to help you make better decisions in the future. In a case like this, right, you could factor a 9 out, right? But then you'd still have an a squared minus 3 situation. That's not going to factor. So what we want to really think about is sort of moving this 27 over to this side, right? And then we would have something squared equals a number. So this is going to turn out to be either factoring, like I mentioned with the GCF, or using the square root method. And in a case like this, if you bring the 1 over to the other side, you're not going to be able to factor. So we're going to have to just set it equal to 0 and use the quadratic formula. Okay. Now initially they all looked the same. We called them all quadratics, right? But that's not enough. Each quadratic can have its own shape and its own structure, which will determine how you proceed. Okay, so let's start with this first one over here. We're looking to factor, and when you look to factor, you should always start with the GCF. What divides evenly or can be factored out of each of these two terms. I already sort of gave that away in the last slide, right? We would say this is 3x times x plus 5, and then we say equals 0. Now the nice thing about factoring is it is doing multiplying or distributing backwards. And most people are pretty good at that. So in your head, if not on paper, you could always do a quick multiply back to see if you did it right. 3x times x is x squared. 3x squared, 3x times 5 is 15x. And it's always good to do this. If you see something that isn't quite right, you can tweak it here before you go any further. Now, what we really have here is a pattern or a model that says something times something equals 0. And the key here is really the 0. Right? If two numbers multiply to 0, we know one of them at least has to be 0. That's not true if we multiply to any other number. Right? There's an infinite number of ways to multiply to 1. I can do a half times 2. I can do a quarter times 4. Right? There's a lot of ways to multiply to 12. So really the key is you have to have this equal to 0. If two things multiply to 0, right, then you know either the first one has to be 0 or the second one has to be 0 or both. So if you want to figure out what would make this 0, what we're going to do here is set this one equal to 0. 3x equals 0. Right? Just divide by 3, divide by 3. That tells us that x equals 0. That's a solution. Or you could set this x plus 5 equal to 0. Right? And you solve this by subtracting 5 on both sides, and you get x equals negative 5. Okay? Quadratics, highest exponent is 2. You might get 2 unique answers. You could get the same answer repeated twice. There could be no solution or no real solution depending on the pattern, but these are our 2 answers, and shouldn't be surprising if you got 2 answers for a quadratic equation. How would you know if they were right? Take them and plug them back in. Plug 0 in for both x's, see if you get 0. Plug negative 5 in for both x's, see if you get 0. Okay. Now you may have to review factoring. There's lots of different factoring techniques. If you're out of practice, it might take a little bit of time to review. But if you have something equals 0 and you can factor it, that's probably the most direct way to do that. Okay. The second equation right here, 9a squared minus 27 equals 0. You have 2 options. You could try to factor. Right? You could take the 9 out and get a squared minus 3. Squared doesn't look so great there, right? Equals 0, right? You can divide by 9 on both sides, divide by 9 on both sides, and you have, I don't think I need the parentheses anymore, you have a squared minus 3 equals 0, right? Because 0 over 9 is 0. Now at this point, it looks like a difference of squares, and if you're comfortable recognizing square roots as in this pattern, you could certainly use that technique. Or what you could do is add the 3 to both sides and get that a squared equals 3. Right? And this is the square root method. If something squared equals a number, then the thing being squared is plus or minus the square root of that number. So that tells us that a is going to be plus or minus the square root of 3. Now plus or minus the square root of 3, just to remind you, there are 2 answers. Positive the square root of 3, comma, minus square root of 3. And if you don't really like the plus or minus or sort of forget what it means, then just write them out separately. There's nothing wrong with writing square root of 3, comma, negative square root of 3. Try to make that look more like a 3 there. But the plus or minus square root of 3 is just a shorter way of saying that. Okay? So, but there are 2 answers, right? Positive square root of 3 and minus square root of 3. Some people, feel okay recognizing this is a difference of squares, a minus the square root of 3 times a plus the square root of 3. And then you have to, set that equal to 0. It got a little bit squished in here, a little bit hard to read. I'm not sure that's the best way to go about doing that. I think that's going to be difficult for some people. So I think if you can get the quadratic, if you're only seeing something squared by itself and there's no other variable terms, you can just move all the constants over to the other side and go that way. Okay. This last one here, right? There's more than, it's more than just x squared. There's also the 5x, so the square root method's not going to work. So we're going to bring this 1 over to the other side by subtracting 1 on both sides, and we're going to start with x squared plus 5x minus 1 equals 0. Okay. So at this point, you might want to try to factor. And if you remember the AC method, right, the A is the sort of 1 in front of here, the B is the 5 here, and the C is the -1. If this factors, we need to find two numbers that multiply to A times C, and those same two numbers have to add to 5, right? And there's no way to do this. The only way you can multiply to 1, right, as integers is a 1 and a 1, and 1 and 1 is not going to make 5. So it's not going to factor. You can't come up with a solution here. So we're going to have to use a quadratic formula. So my A equals 1, right? The signs are important. The B equals 5, and the C equals -1. So when you do the quadratic formula, you have negative B plus or minus the square root, and I always put parentheses in even if I don't need them, b squared minus 4ac, right, all over 2 times a. Okay, I'm going to erase this failed factoring here just because I like to kind of work around where my answers are to help keep myself organized. And I am going to, since I have a screen here, I'm just going to give myself, slide this up a little bit, give myself a little bit more room. Sometimes people don't like copying things over and over again, and sometimes when you do copy things, you make little mistakes. So I like to kind of use the space I have to do the work. So I like to do the 5 squared up here. I multiply all these numbers together first, 4 times 1 times 1, which is 4, and then I do the sign second, negative times positive times negative, that's 25 plus 4, right? And that sort of keeps everything organized so that then I can move across and say, well, this is really -5 plus or minus square root of 29. Oops, and I said 2a down here. That was my giant eraser. Let's do that again. I said 2a and I forgot to fill in the a, right? But I caught myself, and that's why we always show our work. Okay, so getting back to the answer, it would be -5 plus or minus the square root of 29 over 2. And this is the answer here. The thing you always have to look out for with square roots is, can this be simplified? Right? If it was the square root of 36, you'd have a perfect square, and then you'd have to calculate the two answers separately, which actually would have meant this could have factored. Or if it was something like the square root of 28, you would factor that, break that down into square root of 4 times square root of 7, and sort of simplify that square root. But at the core essence, this is the answer, simplified or not. In this case, it can't be simplified because the square root of 29 has no perfect square factors. This is a little bit harder to check your answer, right? Because trying to multiply each of these two answers represented by the plus or minus out, in here is a little bit more complicated. You could always get your calculator out. This is 5 point something. Do -5 plus 5 point something divided by 2. Get a decimal approximation and put that decimal in, and you should get almost 1. Just if you need to do that work to kind of convince yourself you're on the right track. But if you're showing your work here, give or take an arithmetic mistake, you should be all right. Okay, this takes a lot of practice, especially if you haven't done it for a while. You are going to be expected, to do this throughout algebra, throughout pre-calculus, throughout calculus. These should become sort of simple, easy steps. Once you get to this point, you should be sort of in a home stretch and feel comfortable doing this. So, it wouldn't be a bad idea a couple days a week to just generate some random ones, find a website, or just open up an old book, find a few problems, work them out, just to keep that skill fresh. Okay, so you'll have to practice these. Recognize first they're all quadratics, then recognize that different quadratics have different techniques, and then you got to practice each technique to kind of work out all those details.